So my conclusion for today, we've hooked up a actual high voltage laser transformer actually as the secondary, primary and secondary here. Same chokes as last time here. And you know, when we disconnect the circuit, when we break the circuit, goes over 1,000 volts. You know, when there's no circuit connection, it's a broken circuit, and you can just see that voltage just spikes to infinity. Yeah, and only at like 3 volts. So where I'm getting at here is that I can pump all the voltage I want to this thing from a secondary coil, and it just won't bring the voltage any higher. I seem to be at this glass ceiling of about 120 to 140 volts that I just can't seem to break through. And I really think it's boiling down to, the reason is just resistance. There's just not enough resistance in my circuit. Resistance through the inductor, both, you know, physical resistance plus maybe inductive reactance. So there's not enough resistance there at the inductors, but also not enough resistance here at my cells. And what I believe here is that, you know, I've got 36 tubes in series, which brings me enough resistance to get to where I am. However, if I remember correctly, adding more tubes in series from here kind of diminishes the production altogether. So kind of, I believe, is a maximum here. I do want to verify there at some point. The gap in my cells is only about 1 millimeter, just a little bit over 1 millimeter. So my theory is that we need to increase that gap size to maybe 2 millimeters, something to where there's going to be more physical resistance in the cells themselves, possibly even using less number of cells to achieve the same number of resistance, or perhaps even more resistance. But we need more resistance so that voltage has a chance to take over. Voltage drops when there's current flow. That's a known fact of electronics. So when there's current flow, the voltage drops. So we need to curtail the current by all means. So I believe the best way to do that, really the only way to do that, is to increase the gap in each individual cell, and or increase the inductor size and or reactance values to have more resistance. So I believe it's time. We've had these cells for a good while. I believe it's time we start experimenting with more cells as far as the gap size, etc. So I might be embarking on that here soon. Voltage, just, we can't get it much higher, and I believe that's just a matter of the lack of resistance in the circuit. We can't add resistors because resistors will just suck or deplete that energy. It's not going to aid in any way, at least from my experiences. So the resistance has to be magnetically in the inductor over here doing its thing, or in the cell, to where there's just more physical resistance in the water, because we want the resistance to be in the water, because that's essentially like our spark gap. That's where the electricity actually travels. So by increasing that gap, we increase the resistance. Theoretically, by increasing the resistance, we allow for higher voltages at the cell. So that's maybe what we're going to take on next year. Thanks for hanging with me.
This is Stan's Revenge.